This is the brief on why, when it comes to diffusion, the starting line really is the whole race. So, what we're doing here is looking at a really fundamental idea from a couple of angles. The math and the real-world simulations. And it all boils down to this: how the initial condition, which is just the exact starting layout of a substance, totally defines its entire future. Okay, first takeaway. Think of the initial condition as your master map for time zero. It's absolutely crucial. For any process that changes over time, like the diffusion equation, which just tells you how stuff spreads out, you have got to define exactly where everything is at the very beginning. No exceptions. Second, now this starting point isn't just passive. It's what actually creates the energy for anything to happen. If you start with a bunch of stuff crowded in one area, next to an empty space, you've created what's called a concentration gradient. And that gradient, well, that's the driving force. It's what pushes the whole system to spread out and flatten until it reaches a nice, even balance, all while being contained by its boundaries, the walls of the container. And finally, what if you start with everything perfectly uniform, like it's all evenly mixed from the get-go? Well, believe it or not, that's still enough information. As long as you know what's happening at the edges of your space, that uniform starting point is all you need to predict what the concentration will be at any point in the future. So you see, the initial condition is the crucial energetic blueprint that determines exactly how a diffusing system gets to its final resting state.